Hello everyone, today we are talking about the electrons that are transferred in a redox reaction. So this is a simple lesson about taking out what we've learned about the oxidation and reduction of different elements in different redox reactions, taking those numbers and converting that into a look at how many electrons are actually being moved in a given reaction. This will inform us about things like the amount of current that is being produced by a chemical reaction. Since current is so here we go. So let's look at the old copper silver nitrate example again. So once again we have to assign some oxidation numbers. We've done this a bunch of times. I think we've done this in every video here so far. We know that in this case we are actually dealing with ionic compounds and we are dealing with pure metal. So the copper metal is combining with silver nitrate. Silver nitrate's an ionic compound, so we know that the nitrate can be treated as a single unit that has a -1, and that silver then is a actual true +1, which means its oxidation number is the same. Okay, so then the next thing we want to do is we want to look at the conversion of each of these. So I always look at it like this. I have a copper 0, which is converting to a copper 2+, or +2 in this case. We're talking about oxidation number, +2, and so that means that I must have a balance. So if there's 0 charge on the left, then I must have 0 charge on the right. So that means I must be producing 2 electrons. Over here on the top, I have a silver, which is becoming a silver metal here. So I'm starting with an Ag, which is +1, and it is becoming silver metal. So then it must be adding 1 electron. Now the thing to look for is how many silvers and how many coppers do you have? Well, notice that we have this happens only one time, so one time. But up here we have 2 silvers, and that means that it's happening 2 times. So in total, we see that the silver is absorbing 2 electrons. 2 different silver atoms are absorbing 2 different electrons, and copper is producing 2 electrons. So we have sort of we can look at it like this. This is an actual approach you can do, is take 2 times the silver half reaction to a silver metal. So this half reaction, we're doing that twice. And we're going to be doing the copper reaction. And we can see that these two work together very nicely as sort of, if you add them through together, sort of summing, very similar to what we did when we did reaction mechanisms and we had the different steps. So here we're going to get 2 silver plus 2 electrons is going to, plus a copper, is going to be producing 1 silver metal, or actually 2 silver metals because we're multiplying by 2, plus a copper, plus 2 electrons. And just like when we did this in the reaction mechanisms, anything that's on the left and the right gets canceled out. And so what we can think of is that these tell you how many electrons were transferred. So we're in total, 2 electrons are transferred in the balanced reaction. So whenever you are talking about these kinds of questions, they want to know how many electrons are transferred in the balanced reaction. You might have to know how many electrons were transferred, how many electrons were moved in the 2 half reactions in order to determine this. But the answer here is that you need to know how many electrons in total were transferred. How many should have been on the left and the right and were canceled out through this various redox combination. Okay, so let's look at one more example here. here we have hydrogen nitrate, or sorry, nitric acid, of course, which we know is a strong oxidizer. And so that is our one where we're gonna, we have an oxygen, and that gives us a -6 down here. We have hydrogen, which is always +1. So this was where the nitrogen must be +5 in order to add up. So there's a +5. I think I did this in a previous video, so you can always go back and see me work through that a little bit better. Oops, that's cheating. So I have a +1 for hydrogen, that's a rule. Hydrogen's always +1. There are 2 of them, so I have a +2. It has to add up to 0, so I must get a -2. So there's my oxidation state of sulfur. Now if we go over to the nitrate, or the nitrogen monoxide, always assumed at -2, so that means the nitrogen must be +2. Okay, and the sulfur is 0, because it's metal. And there's, of course, an oxygen and a hydrogen we don't really care too much about. Okay, so we want to identify the elements we're interested in. We are interested in the nitrogen and the sulfur because those both have a change of state. And let me change colors. So for the nitrogen, we see a change from nitrogen +5, and it becomes nitrogen +2. So how many electrons did it absorb in this reaction? It must have absorbed 3 electrons in that half reaction. Down here for the sulfur, we see the sulfur goes from sulfur -2, and it changes into sulfur 0. So that means it's actually going up. It's oxidizing, so it is producing 2 electrons. Okay, now the question is, how many times is that happening in a given reaction? In this case, we actually only need to look at one of the 2, or you can you could look at one of the 2 sources of those elements. We could either look at the oxidized element or the reduced element, and we can see here that we have two equivalents of nitric acid. So that means that this reaction on the top here, this reaction is happening 2 times. Over here, we see that there are 3 equivalents of that sulfur. And so there are 3 atoms of sulfur on the left. So this reaction is happening 3 times. So yeah, so that's how I would look at this. And so then we would just look at what does that mean for the number of electrons. It means that we have nitrogen +5, and we have 2 of them plus 6 electrons to give us 2 nitrogen +2s in this reaction, and we have 3 sulfur -2s, which are going to produce 3 sulfur 0s, which is also going to be 6 electrons. So we can see that in total, the electrons, which are kind of they are transferred, so they're produced and used up in the same chemical reaction. We can think that in total, we see 6 electrons are transferred. Another option to look at is to think about this expression as how many electrons this nitrate compound can produce. So, for example, this oxidizing agent, the nitric acid, we can think of that nitric acid produces absorbs 3 electrons. So the oxidizing agent, HNO3, absorbs 3 electrons. So if reaction uses 2 HNO3, then 6 electrons are transferred. So let's try that out in the next example. Okay, so let's look at the next question and see if we can play around a little bit with some of the knowledge we have now about these oxidizing agents and reducing agents. So in this example, I'm just going to work out the various charges here right away. So silver is always +1, which makes the sulfur here as an anion is going to be -2. That's a pretty common oxidation state. This is exactly the same compound we just dealt with, the nitrate, the nitric acid. Here we have it in its, we have more. This is an interesting one because we do have some leftover nitrates, although they're no longer bound to the hydrogen, so it's no longer nitric acid. They're now bound to the silvers. So we can see these silvers are the same silver ions, but now they're joining up with a nitrate in our balanced chemical reaction. Over here we have our nitrate, our nitrogen monoxide, which will be our -2 +2, and a sulfur at 0, and we can put these ones in just for fun. Okay, so let's, I've looked at this question before, and I find that it's still very, very valuable to think about writing out these little arrows and making sure that you're really clear on what elements are changing oxidation states. So only, and especially in this one where we have 2 nitrogen sources on the right, that can be very confusing. So let's just make sure that we're very clear that the nitrogen here is going from N plus 5, it's becoming N plus 2, so that means that we are adding 3 electrons to each of those nitrogens. We are also taking the sulfide unit, and we're taking this S -2, and we're producing S0, which means we're producing 2 electrons. So we can think of the silver, each silver sulfide contains 1 silver atom, so that means that the silver sulfide produces 2 electrons. And the nitric acid, as we said earlier, nitric acid is able to absorb or absorbs up to 3, or absorbs exactly 3 electrons each. So the question here is, how many times does each of these processes happen in this chemical reaction? And we notice that it's easier to look at the sulfur in this case because the sulfur only comes from the it starts in this silver sulfide and it all ends up in the sulfur product. So this occurs times 3, right? So 3 times in balanced equation. So that equals 6 electrons transferred. We can also look at the nitric acid. It's a little bit more confusing because there are 8 nitric acids at the beginning, but we notice that only 2 of them actually carry through to the end product. Only 2 of the nitric acids will actually convert to the end product of nitrogen monoxide. And so this happens 2 times, right? And so that means that we have 6 electrons as well. So the transferred electrons is 6. This means that 6 electrons are transferred. All right, so please try out some of these transfer of electron questions, and we will talk to you in the next video.